Hello guys. So today we are here to solve this spiral matrix 2 problem. In this, just like yesterday we are given, it's the same problem as we did spiral matrix that we did yesterday. Uh, you can find the video of that in the description, the link to that. And in this problem, we are given an integer n, and we need to, so integer n here will be is given 3. So 1, 2, 3, we have to put the element like this, 3, 4, 5 like this, 6, 7 like this, and 8, 9 like this. So we need to do it like this. So how can we, do, I mean to say, create this spiral matrix? So if you see the, last video, what I'm going to do here is the reverse of what I did over there. But I'll explain each and everything in a very clear fashion so that you'll understand what I'm going to do. Okay. So in this, since we are going to return an array of int array. So array of int array is basically a matrix. So we'll be creating one int array. Okay, and let's call this as matrix. Okay, and then it will be new int, and the length and breadth of this is going to be n. That's what it has been mentioned. Generate an n cross n matrix. So the length and breadth is n. Okay, and then we'll be calling this method gen. Gen will be taking this matrix. Gen is basically for generating the matrix. Okay, and matrix 0 0, and then we need to tell one direction. So initially we'll be going towards the right direction, so we'll be passing the direction like this, right? And like this matrix 0, right? And then we also need to have one initial value also. So the initial value that I'm going to pass is this one. Okay, and then at the end we'll just be calling this return matrix. So nothing big over here, and we'll call private void gen. Okay, and then we'll be declaring in the parameter the matrix. So it will be like this, and int row and call. Okay, uh, string direction. Okay, and int start. Okay, start is the initial value. Okay, now in this, first of all, we'll be checking whether our row and column values which are coming as an incoming parameter of the function call, whether they are within the boundary of the matrix. So row less than 0, or row is greater than equal to matrix dot length, or call is less than 0, or call is greater than equal to matrix of row dot length, or matrix of row or call. Okay, so is not equal to. So here I forgot to do one more thing. We need a marker, and the marker is such that which will be telling whether we have already visited some cell or not. So what we are going to do, that we will be filling this this particular matrix which we are passing with the some values. So we are going to do it like this. Like this. Okay. Okay. So with this, we have done it. So we'll be checking here that whether the matrix is cell is not -1. So if it is not -1, then we are going to return. Okay. Otherwise, what we are going to do, that will be, putting this matrix of, so matrix of row, and then this call is equal to, we'll put the start value. Okay, and then we'll be, checking the direction. So direction dot equals, it should be first, we should be going towards right, and after that we will be going towards the equals, right, and then down. Right, down, and then we'll be going towards left, else if, and then directions dot equals up, we'll be going towards up. Okay, like this. So when we are going towards right, we'll be maintaining the same row, but the column will be incrementing. So you see in this, when we are going in the right, the row value will be the same, but the column will be incrementing by 1 in each every, so it will be kind of this call gen will be, the matrix is as it is, row will be as it is, call is equal to call plus 1, and then the next value will be start plus 1, because we'll be incrementing, if this cell is having 1, then the next cell is going to have 1 plus 1, that is 2. But in this call, we need also to check whether we are, we are not falling off the matrix. So how to check that? We can check that by, using this call plus 1 should be less than matrix of row dot length. Okay, matrix of row dot length and matrix of row call plus 1. And also we should be ensuring that the value is, um, I mean to say, it's something unvisited. Then only we should be visiting it. If it is already visited, we should not be visiting it. Okay. So like this we will do. And then in the else case, there is also one else case. Like suppose we are coming to this, then here only will be, firing one else. Why should we be doing this else? Because we want to, this to be, this thing to be, we want this thing to be, taking care of, we want this thing to be taking care of itself. So once this row is completed, automatically it should go, down. So to go down, we have to, maintain the same column. So column value will be the same, but the row value will be, if you want to go down, row has to be incremented. So to increment the row, we'll be doing row plus 1, like this, and start plus 1, yeah, like this. And then, but okay, we have not given the direction here, so we should be writing the direction also, because that is the parameter here. Okay, and then right and down, and in the down call we'll have to, when we come here, then we'll have to do one more check. So here row plus 1, should be less than should be less than matrix dot length and matrix of row row call is equal to -1. Yeah, -1 means it's an unvisited cell. So to visit an unvisited cell, we will be, just pasting it. So matrix row call, and then this down one will be, you should rather be copying this and paste this out. Okay, so we'll be going down, and in the else case, when we, uh, come to this position, I mean to say when the next cell is going to be, this location, then we should not go down, we should rather go left. So to go to left, we will be, we have copied this same thing, and then we can write, it to be left row plus one. We should not be doing row plus one. Now we want to go to left. So to go to left, we'll be doing row and then call -1. Okay. Okay, yeah, like this. So we can remove this. Only one line is there, so we need not have that parenthesis. Okay. So this is done. And when we are going left, we have to, check some conditions. Okay. And the condition will be call -1 should be greater than equal to 0, and matrix of row call -1 should be equal to -1. Yeah. Okay. By habit I'm doing this. So we should be pasting this because we want to go to left. And now after completing the left side, we need to go up. To go up, we need to decrement this row -1, and then we will be, going up. Okay. Okay, and then to go up, we need to do if This will be matrix row -1 call is equal to -1 like this. So basically what we are doing that, we are checking this first line is checking the boundary, whether the incoming call parameters are, acceptable or not. So, and if we have already attached some value in a cell, the, correct value 1, 2, up to whatever value, then, and if it is not equal to -1, then we are returning. And so this is basically, base case of the recursion. So here the recursion, this will, stop the whole process. Okay, so as long as this condition is, as long as this condition is not fulfilled, will be coming inside our method further down, and in this line we'll be setting some value which we want, which we should be setting at the given cell. And here, based on the direction, will be, so this first if is, like suppose here we are here, then this first if will be, going till this point, and once we go beyond this boundary, then rather than going ahead in the same direction, we'll be, going down. And then once we start filling the down cell, then, we'll be keep on going down. Okay, row +1 column down. And once we are about to come to this cell, which is, just outside the boundary of the matrix, then we will, do we'll go left, and while going left, we'll be decrementing the column and keeping the row as the same. And that's how we'll be doing it. And then once we keep on doing it, then we'll be, going there. And then uh, once we, about to go to, fall off the boundary of the matrix, then we'll change our direction, and then we'll start going up. Okay, so we will be going up, and once we go up, then like this, we'll be going up. And if at all we, so once we start going up, we'll be at this cell. When once we are, again jumping, then this cell is not containing -1, so we'll not, go in this direction, and then again we will, change our direction, so we'll be going right. So like that, we are ensuring that we are moving spirally. So let's see how this function, performs, whether any compilation errors are there or not. So yes, some compilation errors are there. So cannot find symbol directions, not direction. Direction is there, not directions. Okay, so one error is there. So let's try to spot that error, how that error is coming. So it is filling the right thing. One is doing the correct job. Okay. Okay, so the bottom row is not filling. Okay, so call +1 is doing the correct job. And then 3, 4 is also doing the correct job. Row is greater than, so might be we are, row is greater than equal to, yeah, that is correct. So that is correct. And row is greater than equal to matrix dot length. Yeah, so we should be call also should be greater than equal to, not like this. So let's check this. Okay, so now that one is fulfilling. Still we have not covered. Okay, okay, So we are going right, then we are coming down. Row plus 1 is less than matrix dot length. Okay. Oh my goodness. We should be doing row plus 1, row minus, like this, row plus 1 call, row call minus 1. Okay. Row minus 1 call like this. Yeah. So now we submit it. Perfect. So this is the way to solve this problem. I hope this thing is clear to you. So in the first line, we are just creating the matrix. Here, let me go back here. So in the first line, we are just creating the matrix. Nothing fancy about it. In this line, we are just filling some marker value, which will tell us that whether this is, unvisited cell, or this cell has been already visited. So if any cell contains -1, it means that that cell has not yet been visited. And if it contains any value other than -1, then that cell has already been visited. Then we come down to this gen matrix 0, 0, right, 1. Okay. So in this function called gen matrix 0, 0, right, 1, we are passing the object matrix. You know that object is stored on the heap. So you'll be actually passing the reference to the matrix which is created in this function. Had it been a primitive type, then you had to return some value from it. But since the matrix is an object and it is stored on the heap, and we are passing the reference to the same location, so whatever changes we are doing in the gen function is reflected in the gen first function. Okay. Now once you come down to this matrix second function, you do row less than 0, row greater than equal to matrix dot length, call less than 0, call greater than equal to matrix row dot length. And these four conditions are there to check whether the boundaries of the matrix are intact. So if we are attempting to go beyond the boundary of the matrix, these four conditions will check that. Okay, they'll not allow that. Okay, and this is there to check that we should only be trampling upon a cell which has not yet been visited. Already visited cell should not be trampled upon. So in both these cases, we are returning. And then in this matrix row call is start, that is the value which you want to fill. Okay, I have passed here 1. So first cell is going to have 1. Now for the next call, I'm passing start plus 1. All the next calls have current value of start plus 1. So they are incrementing the start value. Okay. And then like this, we are doing, we are checking the direction of right. So first we have to go right. So we are calling this, gen matrix row call plus 1, right, start plus 1. Once we are about to go out of this matrix, then we change our direction and call go down, start plus 1. And then again for the down, we go down like row plus 1, matrix row plus 1, call -1. So then again we go down like this. And then once we hit this cell, we change our direction by calling go left. And then we again come to this condition left, and we keep on going left till the we are about to hit the boundary. We are about to go out of the boundary of the matrix. Then again we change our direction and go up. We go by row -1 call. So we decrement the row value, and that's how we go up. And again, after finishing the up traversal, we go again back to the right. So this is how we traverse the matrix spirally in a backtracking fashion. This code is a example of how powerful backtracking and DFS is in solving these traversal problems. And I'm sure you must now be realizing that the DFS is one of the it is the panacea for a whole lot of problems that exist on recursion and backtracking and all those things. So I urge, including me, myself, that we should strive towards mastering DFS. DFS is the algorithm. Okay. So having said that, I would like to, bring to an end to this short session. And if you have any doubt, please push it in the comments. I'll be happy to, answer them. Thanks a lot.